Live. We are live, Yuri, why?
Okay. Hello, everybody. Welcome back to the MeteoTracker Stories Live. Today it's special MeteoTracker Stories since we are going to be live with Alaska. In fact, our guests today are Vladimir ALEXEEV and Alexander KHOLODOV, Arctic researcher at the University of Alaska, which are part of our program of MeteoTracker testing and measurement campaigns. So very extreme weather condition for MeteoTracker. So before starting our conversation, we'd like to inform you that we are again on Kickstarter. We launched a new MeteoTracker campaign, and soon you can find the link in the comments section. We have reached about 70,000 euros on a target of 5,000, but we hope to have much more booking of our devices to be able to deliver as soon as possible to our supporter and fan.
I have to add that tomorrow we have an assembly of the electronic board of the latest version of MeteoTracker. So tomorrow will be hopefully a good day for us.
Yes. Who is willing to support the MeteoTracker project and join the community of our mobile weather station network can pre-order one or more MeteoTrackers at a very convenient price, since for a limited numbers of units, there is a discount up to 40%. Timoteo, as you anticipated, we have some news about the product, both from the hardware side and software features that we have just released, right?
Yes, for the hardware, as I said before, tomorrow will be the assembly of the new PCB with the main improvement is the new USB-C port. And for the software, we have already implemented in our front end on Street a new visualization of data display. It's very interesting, very nice. And also users can from now download their own data on CSV format for further analysis by themselves.
Okay, we will talk about these new features later on. We will show the screen, and so we can go deeper in details. So it's time to introduce our guest, Vladimir ALEXEEV, research professor of Alaska University, and Alexander KHOLODOV of Sasha KHOLODOV, which is a researcher as well in Alaska University of Fairbanks. Thanks for joining us, Vladimir and Sasha. We are very happy to be live with Alaska, which is a wonderful land, and it's a very interesting region for all the weather enthusiasts, since as Vladimir and Sasha will explain us, very extreme temperature can be reached. So, Vladimir, can you tell us what is your field of research?
I am a research professor with background in climate modeling. So modeling is what I do most of the time, but I also have a great respect for people who collect data, and I like collecting data myself.
Very good. Sasha, what about you?
My primary occupation is permafrost studies, and a big chunk of my time effort dedicated to the collection of real data of ground temperature measurements at different places. So we have a broad network of fixed how you call it in your email, fixed meteors, not meteo, fixed stations. And usually, so I do my studies both here in Alaska, and I continue my research in Siberia, in northern Yakutia. We also have pretty good, pretty broad network of ground temperature measurement stations at the Chersky area. And usually at my station, we measure air temperature. At least I'm now trying to do more a broad program of observation and include relative humidity, ground surface temperature, temperature in the upper meter or 75 centimeters, depending on how thick is seasonally thawed layer. And also we have observations in deep and intermediate boreholes, like 15 meters and deeper. And for we call it really deep boreholes if the borehole is 50 or 60 meters deep, like we have here in Alaska in some places. We don't do continuous measurements at this boreholes. We do it once per year, because at that depth we do not see seasonal variation of temperature. We can see only interannual variation, so no reasons to instrument it with data loggers for continuous measurements. But I want to tell again, so if we are talking about more shallow measurements in upper 10 meters, let's say, yeah, we do continuous measurements.
Okay. So, Vladimir, some weeks ago, you have started a measurement campaign with the MeteoTracker in your area in Fairbanks. We have seen many sessions where the spatial distribution of the air temperature is really strongly variable, up to 15 Celsius degrees of variation in like 2 kilometers. So, what do you think about the origin of such a strong variation ratio? And what kind of microclimate study could be performed with high resolution weather data taken on the move as the one that you can have with MeteoTracker?
So Fairbanks is in a valley between mountains. In the winter, when there's no solar energy reaching the surface very often. Well, there's solar, but it's not enough. So in the winter, we have a phenomenon which is called thermal inversion, which is when the surface is much colder than the air above. Unlike people would expect in a normal situation when the air is getting colder when you go up, that's because of the adiabatic distribution of temperature. In our case, when there's no energy that hits the surface, and so the surface itself cools off very quickly, and therefore the air near the surface becomes colder and heavier. Because the air is heavier near the surface, it is becoming super stable. The situation in the atmosphere becomes super stable. It's like a stratified fluid. If you have heavier fluid, it will always go down, and it will almost not communicate with the fluid above. So they are disconnected. And this situation keeps developing if there's no wind. So therefore, we are seeing those strong thermal inversions in the winter, and the variations can be quite significant, 15-20 degrees C. And you can see it on this graph.
Yes, we are showing a session with really sharp temperature variation. As we can see here, we have the global range is more than 14 degrees in a few kilometers. But if we isolate some precise spots, we can measure about, here we have a minus 28.7 and just less than 1 kilometer. We have a minus 19 here, which are 10 degrees less warm. And if we move on the left, so further east, further west, we have minus 15 degrees. So almost 14 degrees in 2 kilometers.
If you show the map, the topographic map, you can see that the blue color is actually in the valley. That's one of the coldest places in Fairbanks. That's a Gold Stream Valley. It's a low-lying area between two small ridges. There's one ridge, you can see it. So there's actually a creek, Gold Stream Creek, and the blue color is exactly where the creek is flowing in the valley. And then when I go up, if you go to your left, you can see the temperature is increasing. I'm going up the hill to Murphy Dome.
Up to 700 meters, correct? Okay.
Yeah.
And here the altitude is about 200 meters, correct?
That's the altitude of Fairbanks, yeah.
Okay. And also, Vladimir, you were saying me that we were talking before the live, that in the inner urban area, you can find very strong temperature variations as well. And you were thinking of a systematic study with MeteoTracker to characterize the microclimate. Can you explain some more detail?
Well, this is a phenomenon which people call urban heat island, and it is very pronounced in the north, again, in the conditions of thermal inversion, when you have localized sources of heating because of super stable stratification and no wind. This heat does not travel too far. It stays in the inversion, and therefore a small heat source is enough to create a significant anomaly because there's no communication with upper air. The wind does not mix up the air, so therefore the anomaly actually stays in place more or less. This is probably not the best for heat. There's a session where I traveled by the river in the middle, and you can actually see more clearly, but still even here you can see that by the Air Force Base you see a little bit of anomaly.
Yeah.
So
then, yes, going west, yes.
Yeah, so I think the warm air up the hill actually kind of hides the signal. Usually you would see a strong signal in the middle here. That's our airport way. Yeah, no, that's not airport. Yeah, it's Mitchell Express. But so normally I actually see a warm signal in the middle by the river where our power plant is and in the downtown. So my idea of doing a little project is actually to create a heat map of temperature anomalies in Fairbanks in the winter and try to see how it relates to large-scale meteorology.
Okay, so Vladimir.
May I compliment a little bit?
Yeah, sure.
Yes.
Yeah, talking about urban environment, so I didn't have that many travels as Vladimir did, but I noticed one interesting pattern. If you stop at traffic lamp for even for 1 minute and you are surrounded by idling car, you definitely can see the signal. So you can the temperature is increasing really noticeably. And also, as soon as when I drive my neighborhood with not so heavy traffic, usually it is again noticeably colder than highways with more intensive traffic. So you have to keep it in mind when you analyze data. Most of your data might be associated. Data you will collect with MeteoTracker will be associated with highways. So it means you have to take into account intensity of the traffic.
This is a phenomenon that is more evident when the air temperature is very low, as you have over there. in Italy is less evident, but we saw big delta between the car engine and the environment.
So yes, so Sasha, the vehicles are releasing thermal energy, let's say, which have an impact that can be measured. Can be measured. So that's the point.
Mm-hmm.
Yes.
Okay.
So, Vladimir, you have many years experience in research, scientific project. What do you think? What can be scientific and research application for MeteoTracker, in your opinion?
I can clearly see a huge advantage for what people call urban meteorology.
Mm-hmm.
You can actually study microclimates on at a very nice resolution. Definitely, this is the tool to study urban meteorology. And one other thing, obviously, you can supply this data to major networks that deal with weather forecasting. So that's high resolution data for any application.
Yes, we discussed this matter with Elena Maximovic and Fabrizio Boardo about the previous live when we discussed how to use high-resolution data to improve local area models for weather forecast. Yes, it's a very interesting topic. Yeah.
And I can tell you, I totally understand what you are only at the beginning of the long, long way. But as soon as your devices, these MeteoTrackers, will be manufactured and used in more or less, not industrial, but and more broadly. So, for example, if you will have like 10 or 20 for Fairbanks, you will have excellent data set. You can check both temporal and spatial variability. Yeah, I see a big future for some of the project I had been involved, or I have kind of my friends been involved. I can tell. Yeah, it's might be very interesting too.
Okay. Good. We are happy to hear these words. Yes. And okay, I'm trying to share. Okay, I would like to show another Alaska session. Okay, just a second. Okay. Okay, this is the lowest temperature we measured so far with MeteoTracker, which is minus 32.9, but it's nothing compared to the record of Fairbanks, as Vladimir told me before. Vladimir, what is the lowest temperature ever recorded in Fairbanks?
Well, I've seen a temperature of negative 60 F, which is negative 50 C. And that is probably not the absolute record for Fairbanks. Well, some 50 years ago, Fairbanks was much colder than it is now. So, and it's one of the things that would be very, very interesting to see how your device performs in super cold temperatures. I know negative 40 is a critical temperature for many batteries.
Yes. MeteoTracker has an operative limit between minus 40 Celsius degrees to plus 125 Celsius degrees. So maybe we can overpass the limits of minus 40 degrees.
Our advantage is that the current consumption is very, very low. So I guess the battery will work till also minus 50 because the hardware architecture. The device is supplied at 1.8 volt. The battery is 3.7, so we have a good margin to work also at low temperatures.
Yeah.
But our refrigerator is like it gets only -27. So you can test.
I'm looking forward to.
So, Vladimir, you were saying that the global warming is manifesting itself in a strong measure in Fairbanks. So you are greatly impacted by the global warming, isn't it?
Well, whenever we do presentations at conferences elsewhere, we always say, at least, I can speak for myself, that we could use some of that global warming in the winter. So it's cold in the winter. So we actually don't mind some warmer winters like we have now, but it does impact livelihoods, and mostly it impacts permafrost, and Sasha can tell much more about permafrost, but we are seeing changes, huge changes right now. So permafrost is changing, and with changing permafrost, hydrology is changing, ecosystems are changing, and therefore, well, the whole chain is responding.
Yes.
And Sasha can say...
Sasha, I would like to ask you about permafrost conditions, and I have heard that the permafrost changes are even further releasing greenhouse gas.
That is very...
a positive feedback that is forcing the climate to change even faster. Is that correct?
Yes, that's very true. So first of all, I can tell you, based on our observation for last few years, we can see. So before we observed the warming of permafrost, now we observe really thawing of permafrost, because at many places, after last few winters, which were either too short or too much snow or too warm, at many places around Fairbanks, I'm not sure how familiar you are with the term active layer. It is a very upper horizon of soil which is seasonally frozen during the winter and seasonally thawed, seasonally unfrozen during the summer. We call it active layer. And in normal condition, if you have a permafrost, by the middle of winter probably, or at least by the end of winter, this active layer is freeze up completely. So for last few winters, at many places around Fairbanks, we recorded what active layer didn't freeze up completely, and it initiates thawing of deep permafrost. And one of the consequences which goes after this thawing is what you mentioned, is a releasing of ancient carbon which had been preserved in the permafrost for at least few thousand years, or go up north, it's a Pleistocene, it's tens or hundreds of thousands of years old carbon. It can be released to the atmosphere in form of greenhouse gases and amplify. But as a local inhabitants, what is more important for us, so if permafrost, in terms of summer precipitation, actually, in a Fairbanks, believe or not, but we live in a desert. So actually, it's totally comparable with the amount of precipitation in Mojave Desert the same season. But we still have nice boreal forests around, and it's all because of partially, of course, a big chunk is caused by the relatively low evaporation rate. But another very important thing is the presence of permafrost close to ground surface, because this tiny active layer helps to keep all this insignificant amount of atmospheric water, of precipitation, the vegetation plants root zone, and supplies vegetation with at least some water in hot, dry summer. But I can tell you, I do my measurements of soil moisture not only in sites where we do have permafrost at the ground surface, but I have a few sites where permafrost is already deeper, and these sites are way drier than permafrost underlaid. And so last summer we were lucky enough, it was pretty humid, so we have decent amount of rains, which helps us reduce number of wildfires, forest fires around. But also, it was first summer I didn't water my lawn on a backyard. Usually I have to contribute a lot of water to keep my lawn green. And this summer was good, but 2 summers before, and according to my measurements of soil moisture, at some places in the middle of July, which was extremely dry in 2018 and 2019, the soil moisture values dropped before the point when plants can consume this water. So plants experience really stress of lack of water. So it's a very interesting and very important thing.
Okay.
Yeah,
you had a nice graph, one of my sessions with strong inversions too. And the heat island, the urban heat island, was clearly seen in that session.
Let me share the screen. Okay, let me stay. Okay, no, it's not the right one. Sorry. Okay, here we go. So you would like to see what session, Vladimir?
The one that you showed before, where
this one. Okay.
No, I think, okay. Let's see. Can you unzoom it?
Yeah.
Can you zoom it out? Yeah. Okay. Yeah.
Okay, here we go.
Well, yeah, you can actually see here, again, the blue color is exactly in the same valley, in the Gulf Stream Valley. And I'm going back from Murphy Dome home. And the Murphy Dome is at about 2,800 feet. And Fairbanks is at roughly 450 feet. So you can see again a lot of red first. I am in the hills. Then I'm going into the valley with the blue color. And then I'm going in town, and you can see that town is slightly warmer, definitely warmer than the blue color. And then for some strange reason, it's getting warmer towards my house. Usually it's colder towards that end, but probably the air is blowing from southeast, and probably that's why.
Brought some.
Yeah, it's.
Yes, we have seen that there is not a predetermined pattern in thermal distribution. Sometimes close to the airport is colder, sometimes it's warmer, and the same apply to the left right area here.
Well, it's actually not heavily populated where I live. It shouldn't be too impacted by heat island, so I assume this is a large scale feature.
Yeah, and if you can pull out my yesterday session, I don't know how easy to find it. Around 5 p.m. in Fairbanks.
And meanwhile, you are, for the people that don't know, you are looking at our front end where there are all the data collected by the community.
Okay.
Each row
is
a
that one,
session.
Sasha? Is this one?
Yeah.
Okay. Okay.
Yeah, I think so. Yeah, if you can go to the very eastern part of the session.
Yes.
Oh, no, maybe not this. Well, yeah, you can see it even here. Yeah, zoom in to the around the red dot. Yeah, the eastern one, the very eastern end. And here you can see the kind of phenomena I noticed. So you see the so the very eastern part is colder when I draw at my neighborhood, which has not so intensive traffic, and as soon as I entered the highway, it became warmer.
Yeah. much warmer. We can have a look by Street View to understand exactly how the, let's say, the orography is.
Yes.
Well, it looks a little different now.
Yeah, it's yes, we have more houses, obviously, but so far my explanation is what intensity of traffic is more important.
Yes.
Okay. The exact spot where the measurement has been done by Street View.
Yeah.
So we can understand if it is urban area or countryside or whatever.
Mm-hmm.
So it's enough also small traffic, because I guess there is not the New York traffic over there. It's an Alaskan traffic. So just a few cars are enough to increase the thermal.
No, actually, no. The main roads, of course, yes, it's not New York traffic, but believe me, the main roads in Fairbanks are pretty intensive. The traffic is pretty intensive, especially at the beginning of working day and end of working day, when a lot of people driving from neighborhood to.
Okay.
Yeah.
We call it.
How many inhabitants in Fairbanks?
So I think Fairbanks itself, it's roughly 50,000 plus minus 50 to 60.
Greater Fairbanks is about 100,000.
But it includes all neighbor like North Pole, Fox, Easter, and of course Elson Air Force Base. So Fairbanks plus Fort Wainwright Base, I believe it's like 60-ish.
Vladimir, I have a question. Before MeteoTracker, probably you were looking at the car thermometer sometimes, right? How do you feel the difference between MeteoTracker and this car thermometer?
Well, first off is the response time, the lag. Car thermometer has about 2 minutes lag time, so more than a minute. And here I think it's probably more than 30 seconds. I wish it was a little shorter than 30 seconds. It probably should be like 10 seconds to measure those sharp gradients. Yeah, but this is the most important difference, is the latency time. And the second thing is the geolocation of all the measurements. That's the most important thing. Because I cannot record my car measurements. I don't want to do it.
So you can correlate the topography with your measurement, with a key factor in analyzing and characterizing the microclimate, I suppose.
Yeah, the streets look empty, but they are not usually. Speaking of our rush hour, we have a local joke in the morning. We call it rush minute. Yes. It's very short. It's a joke.
Mm-hmm. Yeah, it's a joke.
Yes, we have another feature, Vladimir and Sasha. Maybe you can use it. It's the Meteo Photo feature that allow you to take a picture by our app, and every picture has the weather data superimposed on it. I would like to show you an example of this. Okay.
Yes, nice to monitor.
Yes.
It adds some information to the numeric ones, like temperature, humidity, pressure, the point.
Yes, now we are moving to Italy. It is a session made by our friend Luca Lombroso today. So what happens? It's pretty slow. My PC pretty slow today.
I have, if you go ahead. I have one.
I cannot connect anymore.
Okay, I can show if you like. I can show. Dove si? Where is stop coming?
Okay. Second.
Okay. You're sure.
I have a problem with my connection sometimes. Okay, now I should be able.
Yes. You.
Okay.
It's very easy to use.
Yes.
The app. With the app in the menu, there is another menu. Okay. Where you can take the pictures.
This is a MeteoPhoto, so you have temperature, humidity, and altitude taken with the data taken in the exact instant of the taking
It's
the
a
picture.
normal photo with the weather-related header and the footer. Where you have,
Okay, so I can do that too.
Yes,
That should be
you can do it
interesting.
very easy.
And it actually will be very interesting to see whether you will see inversion in vegetation, and very often when we have a strong wind blows above the inversion and it doesn't blow in the inversion, you can see that trees that are above the inversion don't have snow, while so you can actually clearly see the boundary.
Yes, a clear line of separation between inversion and not inversion. So here we have some MeteoPhoto, and as you can see, there is they are placed in the exact spot where they have been taken. So it's an important documentation of weather and microclimate for weather and microclimate. And also, I would like to show you the CSV download. So once you complete a session, you can download all your data, as I'm showing here. I can open the file. Okay. And here we have all the data collected. So we have the time of acquisition, the longitude, the latitude, temperature, altitude, humidity, dew point, and pressure for each point. So you can see how
very
many
neat, very neat, very nice.
May I ask you, are these data available for public now, or you need a special access to it?
You have to ask us special access to it. Yes.
Would you mind if I will share a couple? Would you mind if I will share a couple of my sessions with people? So recently, actually, I will talk to this research team who does studies of urban environment of Arctic cities, and I think they would be really interested in such kind of data, and they might be potential customer.
You can do whatever you want with your public sessions. I mean, you can share public sessions, right?
Okay, great, thank you.
This CSView feature has been released recently, so we are going to enable you, and every buyer of MeteoTracker will be able to download its data, so he can use it as whatever way he wants. Okay, so Timoteo, do you have any other questions for our friends Vladimir and Sasha?
Okay, I want to ask Vladimir if how is it difficult or easy the use of this mini weather station, because it's important for us. We
Well,
also for no expert weather expert people.
I'm not an expert in data collection, and it wasn't difficult. It was super easy.
Okay.
Yeah, it was pretty easy, but I have an experience to communicate with people who collect data for me, like citizen science. You know, when I involved some people who are not trained to any kind of scientific research at all, I can recommend you to prepare at least a brief but very step-by-step manual, like plug it, so charge it before, so to charge it you need to plug this cable into it and then press the button, just step by step with pictures. It will be perfect because you
start that guide. Yes, we have it. Yes.
and
Okay.
yeah, when you will work on it, I will be glad to, if you want, and will send me a draft. I will be glad to provide my comments and suggestions.
Sure.
Same here.
Okay, we'll send you a fast, a quick guide for MeteoTracker. Sure.
We remember that today we have seen only the front end for the data, but we have also the data are also available and visible in the app, your mobile, and you have also some nice feature like a correlation between the map and graphic and the time plot graphics. So you click in one point on the map and will be highlighted the correspondent point on the time plot and vice versa. It's a very useful feature to analyze particular microclimate situations.
So, Vladimir, Sasha, we are waiting for minus 40 degrees as a next step. So, is there any chance to get a cold wave the next days?
I think next few days are pretty warm.
No. Okay. We will
but it will be here. The cold weather will come.
Yeah.
January is the coldest month usually.
Okay.
One more question. How the speed is crucial for your measurements? For example, if I will use MeteoTracker not with my car, but when I do skiing, cross-country skiing, will it work?
Okay. Yeah, it's okay. Yes.
And so there are a lot of people also using bicycling and
so there is various kind of usage for our device. Okay. Thank you, Sasha. Thank you, Vladimir, and thank you, everybody. Next Meteo Stories, we'll see what we will going to discuss.
Thank you for having us. It's a nice contour.
Yeah, thank you.
Thank you.
Yes. Thank you, and keep making sessions. Ciao.
Thank you.
Bye.
Bye. Happy holidays, guys.
Yeah. Merry Christmas.
Merry Christmas.
Merry Christmas.
Bye.